Okay, so I'm going to discuss the next subtopic under history and evolution of quality control and management. From ancient times to present era, quality in ancient times, quality in medieval Europe, and quality in the present era. One thing you must know at this stage that the importance of quality is not a new issue, and since time immemorial, quality has been a serious concern in all that mankind has developed and used. In fact, the quality of civilization, when you talk about, we say that what is the quality of the living standard of the people, the quality of the products, the quality of housing, quality of roads, and this awareness regarding the importance of quality, it's not a new one. It started with the onset of human civilization. But so before we refer to various kinds of tools and techniques we use under quality design and control, we should be very aware of that how the concept of quality used to be perceived in the ancient times. And then from the ancient times, we'll be referring to the medieval ages, and then we'll be referring to the present era, mostly the post 20th century onwards. And you will find that the quality has passed through certain evolutionary process, and as a student of quality, we should be aware of. So, since time immemorial, quality has been a serious concern in all that mankind has developed and used, as I have been telling you. And it has been a constant endeavor of any culture or society to design and develop the finest piece of quality in all walks of life. Okay. So, and there are hundreds such the creations, and they are referred to as, in the history of human civilization, they are referred to as the finest examples of quality. So I will just highlight a few. There are numerous such examples, like pyramids of Giza in Egypt. This is a wonder, in fact. And how could you design and manufacture such a product? High roads and sculptures of Roman Empire, Hanging Garden of Babylon. These are the finest examples of quality. When there are designers, there are quality experts, there are manufacturers, so they have created all these systems or the unique examples of quality. Great Wall of China. This is not hall, it's a Great Wall of China. Ajanta paintings, the Shiva temple at Ellora, Borobudur Buddhist temple at Java, Indonesia. These are the examples. Angkor Wat in Cambodia, Taj Mahal at Agra, and many more. So you are all aware of with such creations. Whenever you make a visit to any place, so you see many creations, and in hundreds such cases, these are the finest examples of quality. Now, this continued for say 1000 years, 2000 years. Now, when you talk about the medieval Europe, so European organizations, European systems has contributed since the days of Renaissance a lot to the field of quality. So in Renaissance Europe, in 15th, 16th centuries, during 14th to 17th century exactly, there had been finest paintings and architecture developed. Craft guilds were formed. In fact, initially when they started creating quality products or quality systems, it was the response for creating quality, it was the responsibility of one individual. So he used to be the designer, he used to be the manufacturer, and he used to be the seller of the products, all in one. Now subsequently, when the demand increased, what actually need to do, that means under the tutelage, under the guidance of one such quality experts. Now the many, the persons are to be trained. And in medieval Europe, accordingly, the craft guilds were formed, guilds, where apprentices used to be trained on quality of carpentry, painting, cloth washing, tanning, masonry, etc. So so this is very unique, I should say, in today's context. Like we have industrial training institutes, we have many kinds of trade tests we carry out, where we try to build in skills among the persons who are motivated, among the workmen and all those. So so this is a must, in fact. So without having skills, how can you produce a quality product? So there are, obviously for creating quality product, you need human labor. So the skills are very, very important. So the craft guilds were formed even during the medieval age, so many centuries back. And in the craft guilds, used to have positions like apprentices, then the journeyman, and the master in craft guilds. Is it okay? So this is, and their focus had been all through. So why don't you become a good designer? And if you become a good designer, we expect that you will be a quality expert, okay, in course of time. There are many such examples, in fact. However, during those days, quality was not considered a formal discipline till the end of 19th century. I mean, it's like individual based. That means under the kingship, the king may find someone who is really, a quality expert. He's having some exceptional skills and the knowledge. So he used to be hired. He used to be, or say, consulted for creating, say, a quality palace or the quality roads, okay, or the quality painting. So there are many such examples. There are great persons, in fact, but this is absolutely individual based. But as such, there has been no formal system to create quality. So quality as a formal discipline has developed during early 20th century in educational institutes and agriculture and industries. That means around 1908, 1910, is it okay, when the 4T model was introduced. Is it okay, it's the mass production, we are going to mass production. And then when you go for the mass production, obviously there is a requirement of the formalized system, and that system is a quality system. So for the last 100 years or so, the quality, the discipline exists as a very unique the discipline. Subsequently, it has emerged as a discipline in service organizations also for the last 50 or 60 years also, like hospital, banking, transportations, and etc. And during this, the last 100 years or so, particularly the contribution made by the military organizations, the defense establishments, is something very the tremendous the contributions they had, all the defense establishments like US Department of Defense and many other defense organizations. The idea has been very clear that unless you have a quality weapon, you cannot win the war. So many such new tools and techniques, they were developed in the field of quality during the Second World War days, and later on those tools and techniques, those approaches were successfully implemented or adopted for civilian products. So in today's organizations, the issue of quality is given utmost importance. You cannot name a single organization anywhere in this world where the quality aspect is not considered. And we really concerned about, in many cases, how to improve the quality of any systems. And it's a continuous improvement philosophy. That means even if the quality is considered to be the best, but you say even best can be bettered. There are many examples, in fact. So the quality in the present era is basically managed quite differently than it used to be even 30 years ago. First thing is, in order to consider the quality aspects in products, in components, in the systems, okay, what you need to do, you must have a formal system. So the modern quality has evolved through a number of stages. That means starting in 1910, 1920s, then it used to be the inspection-based quality control. That means if you want to focus on quality, you say, why don't you create an inspection department? So the quality activity used to be equated with the inspection-related activity. Later on, during 1940s, 1950s, we brought in the concept of quality control. That means while the process is on, obviously I have to maintain the quality of each and every component which I produce. So it is essentially, we try to have an online real-time control systems at the shop floor. So we started talking about quality control, and then here the utmost importance is given to so the quality of a component. It's not the quantity. There are two aspects. One is the quantity and the second one is the quality. And as you may be aware that in many cases we say that if you focus on the quantity production, there is a high chance that you may neglect the quality aspect. So in that context we say that you may be slow, you may not be that productive, but never you compromise on the quality. So the quality is job number one. Now next in the 60s onwards, now we moved from quality control to quality assurance. That means here is an assurance system. I don't bother about its quality check. I don't bother about inspection. I am assuring you that the component which I produce, it will be a quality product. There will be no defects, there will be no defectives. So that sort of assurance system you have to create, and then only, and there are many such examples, and then only it is referred to as the quality assurance system. And later on, up to the quality assurance, we say that I have my direct activities mostly related to the product manufacturing. So I will be concentrating on that. But I may not concentrate on the indirect activities, like say the maintenance, like the security, like the material handling, like say, the purchase systems. So these all supporting systems actually creating or supporting the production systems. So you need to look into all sorts of supporting systems and their quality. So when you consider all this, we move from quality assurance to total quality control or total quality management systems. And this is also referred to as the company-wide quality management. That means while all the subsystems of a company or an organizations, they must have the quality standards, and they try to improve in their performance. Is okay, and it's a never-ending exercise or never-ending activity. So when we are concerned about or we are really interested in incorporating quality in all sorts of systems, not only in the production systems, then it is referred to as the total quality control systems. So if we look at the characteristic features of a modern quality systems, okay, means we refer to sometimes a benchmark system. Means as a student of the quality control and the design, you should be aware of that what is the best systems the mankind has created with respect to the quality features. So when you look at such systems, and there are numerous such organizations, you study their quality systems, and in the today's context, you will find that these quality systems, which is sometimes referred to as a modern system, okay, it has got some specific features. So as a student of quality, you should be aware of. First one is the customer focused. That means there must not be any argument with the customer. That means the product which I am going to sell to the product. That means the quality, I will incorporate quality in that product as demanded by the customer. Is it okay? It is not that what I want to deliver to him, but what I feel that this should be the customer the requirement. So it should be based on the fulfilling the customer requirements. Then any exercise at quality, it's essentially an exercise for quality improvement. Obviously there will be an assessment, but once you assess the quality or the quality systems, obviously there will be some deficiencies, there will be some gaps, and it is implied that once the gaps are known, the deficiencies are known, you have to think of implementing ways and means to improve the quality level. That means from say one specification level, you have to move to the next specification level. Okay, so one level of fitness for use, you must go to the next level of fitness for use. Okay, so I must believe in the concept called even best can be bettered. If I feel that I have reached to the best systems and no further improvement is required, essentially you lose your credibility or credential as a quality expert or as a quality student. Everyone's specific responsibility for quality. That means you must believe in a total approach. It's not that the quality is the responsibility only of the worker. Obviously, he will be creating the quality among the parts which he produces. But I must also look into that this is the product quality is very much dependent on the process quality. So as a process engineer or the process designer, I also must be aware of the ways and means or ways and methods which I am supposed to implement or supposed to use to improve the quality of the process. So normally what we do in order to improve the quality of the product of a process, we need to focus on the settings of the process. That is very, very important. So many a time the process engineers involved in quality improvement exercise, they look into these aspects. Is it okay? Later on we'll discuss all these aspects, how to reach the best possible process settings so that the product quality is assured. And just at this point in time, I should highlight that there is, this product quality is very much related to the process quality. These are interrelated. That means, and with respect to the process quality, it's a total systems you have to create where everyone's specific responsibility for quality must be known. And defect prevention oriented, not defect detection focused. This is very, very important in fact. Like say, the prevention of, suppose the defect detection, essentially inspection based quality control. So essentially when you just only bothering about the inspection and that the inspection, that means I will be producing some 1000 units say, and I know that the production system is so complex that all these 1000 units cannot be defect free. Is it okay? So what I need to do, that means I expect that always there will be some defects or the defectives. Now I create an inspection system and I will be very prompt in identifying all these defects or the defectives. So that is the detection, the defect detection based, but that is actually not a quality improvement exercise. Whereas what you need to do, that means I must know that what are the causes for the quality deficiencies, and I will create the system in such a way, I will design the product in such a way that there will be prevention of, say, the defective items or the defects while I produce the product. So the basic message is defect prevention, not defect detection. So that should be our goal for quality improvement, and ultimately it must become a way of life, part of organizational systems. Now, we come across several types of manufacturing systems, and for example, the manufacturing systems are grouped under three categories. One is, at one extreme you have the job shop, at the other extreme you have continuous processing, and you have the batch production. So that's why I have written job shop, batch production, or continuous processing, like say a chemical plant. Okay, so the batch production, normally the repetitive manufacturing, like say the car manufacturing systems, and there are numerous the job shops we have. Now here, in any kind of manufacturing systems, quality of products, processes and the systems is the prime concern. It's means never you assume that only I will be looking into the product quality. So I must also simultaneously look into the systems quality as well as the process quality. Now, variability in quality characteristics of the dimensions needs to be under control. That suppose your the specifications is say 20 plus minus 0.01. That means the tolerance range is say 19.99 to 20.01. Is it okay? So that's the tolerance range. That whenever you produce one unit, you check whether that exact value, is it okay, whether it is within this range or not. If it is within this range, you say it is conforming to the specifications and you accept it. If it is outside of the specification range, is it okay? Suppose it is say 20.5, obviously you are not going to accept it. So obviously when you produce 1000 units or 10,000 units consecutively, the same value you cannot get. That means there will be variability, unavoidable. Even if it is the most sophisticated systems, each and every dimensions cannot be the same. Is it okay? So under these conditions, what you need to do, that means you must get an idea about the variability with respect to the quality characteristics. So sometimes we say that this variability must be under control, right? So sometimes we say that any exercise on quality is essential an exercise on variability, and this variability should be measured, and you have to take actions, you have to take measures so that the variability gets reduced. And for controlling variability, you need to consider many options or many alternatives, like the changing of say the raw materials, or so the changing of say work holding devices in a machining operations, or the changing of the basic technology you employ. So one thing we should be aware of, any exercise or any assignments we carry out on quality control and improvement, essentially at the ground level it is an exercise on variability. Later on I will just tell you that how many different ways, what are the alternatives available you have with you to measure variability when the data are collected. Okay, so here just I want to focus two things, that is the variability. In any quality related improvement exercise, there are two specific goals. Okay, first one is the variability needs to be under control. That means if the variability is measured with sigma, suppose sigma today is 0.25, okay, with respect to a particular quality characteristic. Now you have to think of ways and means to reduce this variability. That means whether this 0.25, this is the value of sigma, whether it is under control or not. So this is the necessary condition. Now you always talk about improvement. So improvement, that means whether you can reduce it from say 0.25 to say 0.15 in one step or multiple steps. So that is basically controlling variability or reducing variability. So that is a sufficient condition. So any exercise on quality, you must remember two things. First thing is, what is the present level of variability, whether this is under control or not. Once this is under control, next you think of how to reduce the variability. So while dealing with a quality related variable, we may use any or more of the following three measures of variability. Like say the range, it is an inaccurate measure, but sometimes we take a sample of the values related to a particular quality characteristics. This way you collect data. That is the first level. Is it okay? So what you try to do, that means in a sample of size n, so n maybe say 100, n maybe say 200, n maybe 25. So you have to select the sample size based on certain rules. So later on we'll talk about this. Like whenever we say we look into developing the quality control techniques, so the starting point is the formation of sample. So in a sample, when you get say some 10 such values, so you have a maximum value, you have the minimum value. So the difference between the maximum and the minimum, it is referred to as the range. So you please note it down, an easy but approximate measure. That means if say the value of n is greater than 10, obviously it may not be that accurate as a measure of dispersions or the variability. But in many a time when you deal with the variables data, the sample size is kept within 10. So this may be acceptable to you, range as a measure of variability or dispersion. The most accurate measure is the standard deviation, most correct measures. Okay, so obviously you are aware of how to measure the standard deviation for a sample. And in certain cases, we also measure variability or dispersion with interquartile range or the IQR. So while you carry out the exercises on this, okay, so later on, so we'll consider all these aspects. So depending on the type of problem, depending on say the accuracy level you want, obviously you have to select the appropriate measures. Now this is one, and thank you so much, and I hope that in the topic, all these subtopics, we are creating a mindset. That means I'm giving you a total view, and ultimately this is the base we are trying to create. Is it okay? So thank you so much.